Good morning, cadets. We have concluded the mechanical properties of matter. Basically, mechanical properties of solids and fluids. So, in the case of fluids, we have studied first fluids at rest, that is fluid statics, and fluid in motion, that is fluid dynamics, and thus we concluded. Now we are discussing another very important property, that is thermal properties of matter. As you know, matter may be solid, liquid or gas. Thermal means what? Thermal is related to heat. Thermal is the word related to heat and the changes that take place due to heat. So we all have common notion about heat and temperature. In this cold winter, when we rub our palms together vigorously, in the cold morning and hold it to our cheeks, we feel warmth. Means by rubbing our palms against each other rigorously, warmth is developed. The palm's surface became warm. How is it? Here we see the work that is done against the friction. When we rub our palms against each other, there is a friction. So we feel the friction. When the work is done against the friction, it is converted into warmth, that is heat. In common notion, we call it as heat. Similarly, you might have seen so many things. Sharpening of a knife. When the knife is getting sharp, you might have seen the sparks being produced. And when you hold the knife edge after sharpening, it will be very hot. Isn't it? So, when the work is done against the friction, the mechanical energy is converted into heat energy. What does it mean? Whenever you consider a solid or liquid or a gas, at normal temperatures, they will be having their molecules bound in their own positions. When the same solid, for example, let us say this desk, metal desk is kept in the hot sunlight, it becomes warm. After half an hour or 1 hour, if you try to go and sit on that desk, you cannot sit, it will be so hot. Then suddenly what happened? There is a rise in temperature. The metallic surface will have rise in temperature. How is this rise in temperature? The metal has received the energy from the sun. That energy we call it as thermal energy from the sun. We call it as heat from the sun. As a result of which, what happened to the molecules of metal of the desk? Molecules of the metal, after receiving the energy, start vibrating in their own positions. They cannot move out. Like in the case of gas, the molecules can move out the moment they receive energy. Their kinetic energy increases. Whereas in the case of metal, the molecules can just vibrate up and down or to and fro, back and forth about their positions because these molecules are closely packed. As a result, what happened? There is an increase in their internal energy. As a result of increase in their internal energy, there is increase in their kinetic energy. As a result of increase in their kinetic energy, the temperature of that metal increases. Okay, so this internal energy term that we use as a result of receiving heat, as a result of receiving thermal energy from the sun, is due to mainly the configuration of the molecules and the potential and kinetic energy of the molecules. So, as a result of receiving the energy, the kinetic and potential energy of the molecules increase, and thus their level of heat content increases. As a result, it leads to rise in temperature. So, in this topic, we are mainly discussing about heat and temperature and what are the effects of heat. What are the effects of heat? As a result of heat, when a body becomes hot, its temperature rises, and there are so many other changes also. The expansion of the solid can take place. Not only expansion, the change in state of matter can take place. Ice melts to form water. Water, when it is heated strongly, it becomes steam. It boils and then converts into steam. So there is a change in state from solid to liquid, liquid to gas as an effect of heat. So all these things we are going to learn in this particular topic. So before we go into the details of all the thermal properties, we should learn what is the meaning of heat and what is the meaning of temperature. Heat and temperature. Just to give you simple example, take 2 tumblers. Fill 1 tumbler with hot water, another tumbler with cold water. 1 tumbler with hot water, another tumbler with cold water. Keep your right palm in the hot water tumbler, left palm in the cold water tumbler. What do you feel? The left hand feels cold and the right hand feels hot. How is it? Our body has got its own temperature. Healthy human body is about 37 degrees Celsius. Its temperature, healthy human body temperature is 37 degrees Celsius. When we keep our palm in the right palm into the hot water tumbler, we feel hot because the temperature of that water may be greater than 37 degrees Celsius. Let us say temperature of water is say 50 degrees Celsius. So there is a difference in temperature between our body and the hot water. 50 minus 37. There is a difference of 13 degrees Celsius. Therefore we feel hot. So there is a transfer of energy, transfer of thermal energy from the hot water to our hand. Similarly, when we keep our left hand in the cold water, suddenly we feel cold. That if it is of ice cold water, we cannot keep it for a long time. Suddenly we take out. It will be very cold. What happens in this second case? Ice cold water, let us say it is at 0 degrees Celsius. Our body is at 37 degrees Celsius. So the heat transfers from our body into the cold water. When there is a transfer of energy from our body into the cold water, we feel cold. So heat is the energy that is in transit. Heat is a form of energy. Definitely it is a form of energy. It is a thermal energy. It is a energy that is in transit. The energy that is transferred from one system to another system, from hot body to cold body. So we define heat as the form of energy which is transferred. It is transferred from one system another system at lower temperature. Lower temperature. So the system at higher temperature we call it as hot, and system at lower temperature we call it as cold. Or in simple terms, the energy transferred from hot body to cold body or to cold surroundings, you can say, cold surrounding, is called heat. So there is a transfer of heat from hot body to cold surrounding until both of them attain same temperature. To give you example, when you keep hot tumbler of milk for some time, within 5-10 minutes, if you observe the milk, hot milk becoming cool, it goes on becoming cool, it transfers its thermal energy to the surroundings. Similarly, if you keep a glass full of ice, when you observe after 5 minutes, 10 minutes, you will find the ice turned into molten state, the ice turned into water. And then slowly after half an hour, 1 hour, you will find water becoming warm. So there is a transfer of energy from one system to another system. In the case of hot milk, of tumbler of hot milk, there is a transfer of thermal energy from hot milk to the cold surroundings, which is at room temperature. When you observe ice cold water or glass filled with ice, after half an hour or after 1 hour or 2 hours, if you observe, it will be attaining the temperature of the surrounding. So there is a transfer of heat from the surrounding into the cold system of ice. So this energy transferred from hot body to the cold surroundings is called as heat. So this is transferred until both systems attain same temperature. Same temperature. This is called thermal equilibrium. We will discuss about thermal equilibrium and all later. Thermal equilibrium is the state after which there is no further transfer of thermal energy. So this energy in transit from hot system to cold system until both the system attain thermal equilibrium is called as heat. Now what is temperature then? Temperature, as you know, is degree of hotness. Or coldness, which can be felt, degree of hotness or coldness. So, by noting down the temperature of a system, we can quantify the heat. Indirectly, we can say how much heat the body has can be understood by the knowledge of temperature. The level of hotness or level of coldness is understood by the degree of hotness, that is called as temperature. So it is measured as degree of hotness or coldness. Now, what is the SI unit of heat? SI unit of heat is nothing but the SI unit of energy. Heat and energy. Heat is a form of energy. Therefore, SI unit of energy is joule, which is symbolized as capital J. Then what is 1 joule? 1 joule of the heat is that energy which, when supplied to 1 kg of substance, it raises its temperature by 1 degree Celsius. 1 joule is the amount of heat required to raise the temperature of 1 kg substance by 1 degree Celsius. So SI unit of heat is joule. There are other units also. Another unit is calorie. It is a older unit. Calorie. Its symbol is Cal. Calorie is also unit of heat. It is not SI unit. It is a unit of heat. Calorie is the amount of heat required to raise temperature of 1 gram of water by 1 degree Celsius. So we define calorie as amount of heat required to raise the temperature of water, to raise the temperature of water of 1 gram by 1 degree Celsius. If you take 1 gram of water, if its temperature is to be increased by 1 degree Celsius, how much heat is required? 1 calorie is required. But as the temperature range changes, the amount of heat required also changes. So specifically, this calorie is defined for only one particular interval, that is from 14.5 degrees Celsius to 15.5 degrees Celsius. From 14.5 degrees Celsius to 15.5 degrees Celsius. So this is how we define calorie. Then there is a relation between calorie and joule. It is found out that 1 joule is equal to 4.18 calorie. 4.18 calorie. It means in order to raise the temperature of 1 gram of water by 1 degree Celsius, it requires 1 calorie. So 1 calorie is equal to 4.18 1 joule. There is a correction. There was confusion. 1 calorie is equal to 4.18 joules. So 1 kilocalorie. 1 kilocalorie means what? 1 kcal. 1 kcal is equal to 4180 joules. 4180 joules. It means what? If you want to raise the temperature of 1 kilogram of water by 1 degree Celsius, it requires 4180 joules. 4180 joules, which is equal to 1000 calorie. 1000 calorie. So we have defined here amount of heat required to raise temperature of 1 gram of water by 1 degree Celsius is 1 calorie. It means it requires 4.18 joules. 1 calorie equal to 4.18 joules. It requires 4.18 joule of heat energy is required to raise the temperature of water of 1 gram by 1 degree Celsius. In this temperature range, 14.5 degrees Celsius to 15.5 degrees Celsius. It means as temperature range changes, even the heat required also changes. But 1 calorie is exactly defined for this particular range of temperature. Okay, I think you got the point. What is the meaning of temperature? Based on the level of temperature, we can quantify the heat content of that particular body. Okay, we are going to learn in detail about the specific heats and all. There we will learn about the meaning of the heat, calorie, relation between them in detail. Okay. Now, measurement of temperature. That is what we call it as thermometry. Now we are going to study the measurement of temperature. We all know that temperature is measured using thermometers, and we are learning about how temperature is measured with thermometers. Which property is being used? What is the basis of the thermometer? Okay, so measuring temperature is also called as thermometry. Thermometry. So thermometry deals with measurement of temperature. Measurement of temperature. You know, measurement of temperature is done with a device called a thermometer. We are familiar with two types of thermometers: mercury thermometer and alcohol thermometer. So they are called as liquid in glass or liquid filled in glass thermometers. They are usually mercury and alcohol filled thermometers. So they have got the advantages. Mercury is the only liquid metal. Mercury is the only liquid metal which has got a very good thermal expansion, coefficient of thermal expansion. It responds very well to the heat. The property that is used for both of these liquid filled thermometers is the property of expansion. The volume of these liquids takes place due to heat. Volume expansion due to heat. This is the basis of thermometer, or you can say principle of thermometer. The volume of a given liquid expands linearly as the temperature rises. Contracts linearly as the temperature falls. That is the principle of using mercury and alcohol thermometers. Mercury has advantage that it is a only liquid metal and it is having silver color, silver luster, shining property. It has a shining property, and very important thing is that it doesn't stick to the glass. It is non-sticking liquid, as we have studied, and it has got good thermal expansion due to heat. Because of these advantages, mercury thermometers are usually used. But where do we use alcohol thermometers? Alcohol thermometers are used where the temperature is very low, like glaciers, regions of glaciers, Siachen glaciers and all. In such cold regions, alcohol filled thermometers are used. The advantage of alcohol is that even at low temperatures, it doesn't freeze. The freezing temperature of alcohol is 112 minus 112 degrees Celsius. You can just imagine. Freezing temperature or freezing point of alcohol is minus 112 degrees Celsius. Minus 112 degrees Celsius. Whereas freezing point of mercury is minus 38.8 degrees Celsius. Minus 38.8 degrees Celsius. So mercury thermometers are not used in cold regions. Alcohol thermometers are used in cold regions because its lowest freezing point is freezing point at which the alcohol becomes ice. Alcohol gets freezed to form solid alcohol at minus 112 degrees Celsius. Okay, these are the advantages of using mercury and alcohol. Water cannot be used in the thermometer because water sticks to the glass surface, and water has the property of evaporation, and it will condense also. Therefore, water is not used in the liquid filled thermometer. Okay. Now, when we spoke about Celsius, degree Fahrenheit, Celsius and degree Fahrenheit, Celsius and Fahrenheit, these are the two scales using which temperature is measured. So there are two scales. Scales of thermometer or scales of temperature. Celsius and the one Fahrenheit. Celsius is written as degree C. Fahrenheit is written as degree F. Celsius and Fahrenheit, these are the scientists who devised the thermometers. So, to construct a thermometer, two levels are to be fixed, two temperatures are to be fixed. So, two levels which are fixed are basically ice point of water. Ice point of water. It is also called as freezing point of water or freezing point. It is taken as 0 degrees Celsius. 0 degrees Celsius. And that of Fahrenheit scale, it shows 32 degree Fahrenheit. Another one is steam point of water. Steam point of water. Steam point of water is also nothing but the temperature at which the water boils. It is also called as boiling point of water. Boiling point of water. Boiling point of water is taken as 100 degrees Celsius, and here it is 212 degrees Celsius. 212 degrees Fahrenheit. Fahrenheit. So you can see here, between 0 to 100 there are 100 intervals, 100 graduations, 100 intervals. Between 32 to 212, if you take the difference, there are 180 levels, 180 intervals or graduations. Between 0 to 100, 100 intervals are. So using these two fixed points, these are the fixed reference points. Using these two fixed points, the thermometers are devised. The thermometers are devised. The thermometer that is used in our laboratory, it is called as laboratory thermometer. The laboratory thermometer is having both Celsius scale as well as Fahrenheit scale. On one side you will find Celsius intervals, on the right side you will find Fahrenheit scale, that is Fahrenheit intervals. On the Fahrenheit intervals there are 180 graduations between 32 degree to 212 degree Fahrenheit. And for Celsius, between 0 to 100 there are 100 equal graduations. So Celsius scale has got an advantage. Okay. Now when we try to relate between them, then we get interesting relation. Temperature in degree Celsius minus 32 divided by 180 becomes equal to temperature in Fahrenheit divided by 100. Look at the relations once again. How Fahrenheit scale and temperature scales are related. Temperature in Fahrenheit minus 32 whole divided by 180 is equal to temperature in Celsius divided by 100. So this is the relation between temperature in Fahrenheit with temperature in degree Celsius. So with this relation we can find out if temperature in degree Celsius is given, we can find out temperature in Fahrenheit. Or if temperature in Fahrenheit is given, we can find out the temperature in degree Celsius. So this is the relation between temperature in degree Celsius with temperature in Fahrenheit. We will come to know that they are linearly dependent. So if you take 180 this side, then temperature in degree Celsius into 180 whole divided by 100 becomes temperature in degree Fahrenheit minus 30. So if you cancel this, 2 5s are 2 9s are 2 5s are 2 9s are. So we get 9 by 5 times T F 9 by 5 times Tc temperature in Celsius. 9 by 5 times Tc is equal to Tf minus 32. 9 by 5 is also equal to 1.8 C. So we can also write this as 9 by 5 Tc plus 32 equal to Tf. 9 by 5 Tc plus 32 is equal to Tf. So this is the relation between temperature in degree Celsius with temperature in Fahrenheit. So if we draw the graph of Tc versus Tf, we get a straight line graph, because this is of the form y is equal to mx plus c, where m is the slope of the graph 9 by 5, x is the variable, that is temperature in degree Celsius, and 32 is the intercept. That we will see by drawing the graph. When we draw the graph of Tf versus Tc, we get a straight line, because this represents a straight line, equation for a straight line. So if you just draw, so this becomes straight line graph, and this interceptor is representing 32. Means this becomes 32 degree Fahrenheit, and this upper point becomes 212 degree Fahrenheit, and corresponding to TC, temperature in Celsius, this corresponds to 0 degree Celsius, and here this corresponds to 100 degrees Celsius. So between 0 to 100, delta T C corresponds to 100, and between 32 to, if you draw a slope, you see, if you draw a slope between 32 to 212, there are 180 degree Fahrenheit. So that is equal to delta F. Okay. So if you take this delta F by delta T, delta TF, it is not delta F, it is delta TF. Delta TF by delta TC, you get 180 by 100, which is 9 by 5. So this itself becomes m, that is slope. So slope becomes 9 by 5, and the intercept is 32. Therefore, we can write TF is equal to slope. Slope is 9 by 5 into TC plus 32. 32 is the intercept. So this is of the form y is equal to mx plus c, which you have learned in maths as an equation to describe a graph, straight line graph, where x and y are linearly dependent. Therefore, here TC and TF are linearly dependent. So with this relation, we can find out the temperature in Fahrenheit by the knowledge of temperature in degrees Celsius, and vice versa. Now, one interesting question is that at what temperature both Celsius scale and Fahrenheit scale show same level, same reading? Question is, at what temperature both Celsius and Fahrenheit scales read same value, read same value. I gave this question when we were ninth to find out this. You take TC is equal to TF. At what temperature both Celsius and Fahrenheit scales read the same value? So let TF equal to TC equal to some value, let us say x. Put in that equation. Then x is equal to 9 by 5x plus 32. Now you can find out the value of x. 9 by 5 minus x. 9 by 5x minus x is equal to minus 32 by rearranging the terms. So 9 by 5 minus 1, it becomes 0.8. 1.8 minus 1, it becomes 0.8. Thus you can see, after simplification, x becomes equal to minus 40 degree. Means at minus 40 degree Celsius, both Celsius scale and Fahrenheit scale show the same values. So this is interesting question. So in Siachen glacier and all, the thermometers which are used are usually alcohol filled thermometers. You will never use mercury filled thermometer because mercury freezes at minus 39 degrees Celsius. So temperature falls below minus 40. It may go up to minus 45, minus 50 degrees Celsius. Okay. We will continue this in the next session. We will discuss about another type of thermometers that are called as gas thermometer. Constant gas thermometers. Okay. Constant volume gas thermometers in the next session. Thank you. Have a nice day.